Let me know if my screen is, the PPT is visible actually.
This recording started, but have you started to share?
Yep. I shared the.
Okay, it's coming now. It's coming now.
It's coming out.
Coming still, it is not visible. Just it's coming. Yeah.
Okay. The presentation. Right. Today I'll just have a little briefing on the data center and how it is getting connected. We have seen the data center part, but this is little more briefing about it. So I'll try to cut short few things because we have already seen in the overview of data center. Okay. So this is a full data center architecture training. Okay. So you'll be seeing about the entire infrastructure. I once spoke about DMZ, that is demilitarized zone. Okay, and then HA, high availability, DR, monitoring. Okay, so in order to have the data center to get operated, what you need is first the internet. Of course, you need the physical devices. From internet, there is router. Okay, so internet, any ISPs, they doesn't give us directly. So this all the internet services will be routed through the router and the modem. Okay, through that the connectivity comes in through the firewall of that particular server. In one rack, first view at the top, you will have a firewall. Through that, you will then get the network connectivity to the switches and then to the server storage, everything. So, so the mini, not mini, I wouldn't say mini, micro data center, which the suggestion which we provisioned to one of the client is like they wanted around 200 TB storage, where it's a different laptops that they use, like few have Mac, few have Windows, and then almost 10 employees are there. It's a small company, and but in a day or in a month, they almost used to store 10 TB of data. So they wanted a small solution to be provided, a storage solution, where they don't have to expand this for almost 5 years at least. Currently, with the cloud storage, what they are doing is they are not happy about it, and they don't want the cloud solutioning, so they want an on-premises solution. So that's what we built, and I walk you through on that solution. So they have a Airtel Wi-Fi. Okay, so through Airtel Wi-Fi, so of course Airtel is the ISP, internet service provider. Airtel gives internet, the broadband internet. Via broadband is a channelized internet. Okay, so you will be guaranteed, if in case you are taking 1 Gbps speed per second, then you will be guaranteed that you will be getting that speed. If you take it in the shared environment, the network bandwidth will be shared to multiple people. So at times you will not get the speed that is being committed when you use it in the Wi-Fi. Okay, so that's the reason everybody go for the broadband internet. Broadband internet is something like, if it is committed like 500 Mbps is committed, then you will be definitely receiving that speed. So the internet speed test can be done through a simple basic test. So you can open your browser Chrome and type internet speed test. So you will get check your internet speed test. Once you click on that, you will know your download speed and your upload speed. Okay, so through that you will just confirm your internet service provider whether you're getting the enough speed. If in case some internet service provider tells you you are getting 500 Mbps, and when you try to run that internet speed test, it says only it shows only 200 Mbps. In that case, you can definitely defend to your internet service provider whatever the committed internet speed, you are not getting it. So in that case, you can upgrade or you can downgrade your internet speed. Okay. So, and the latest modem that has come is a mesh modem, and it has got Wi-Fi 7. Latest one is Wi-Fi 7. I just migrated to Wi-Fi 6, but I just heard that before few days the Wi-Fi 7 modem has been launched. But most of them will be using Wi-Fi 5 or Wi-Fi 4. If in case you wanted to know what is the modem you are using, so broadband will be connected to your modem. Through that modem, your Wi-Fi works. You will be having antenna in the modem, and through which like your gadgets, like your mobile phone, your laptop, your TV, everything will be getting connected through that, right? So in order for you to check the internet speed, as I said, you can connect to the Wi-Fi or through the LAN cable and just go to Chrome or Internet Explorer, type internet speed test. You will get a button, click on that. You can see the upload and download speed. Similarly, if in case you want to know what is the modem you're using, that is the physical device you're using, probably you can just take the device, look what is the, whether it's Wi-Fi 6 or Wi-Fi 7. I'm sure not Wi-Fi 7, not launched in many places, only industries are using now. Wi-Fi 6 is the max they have given to the residential area. You can see if it is Wi-Fi 5 or 4. If you're using Wi-Fi 5 or 4, it is little um, downgraded device now. So you can just ask your internet service provider to upgrade to 6. Mesh 6 works, captures a very good speed. So you can check that, or if you're not sure, if it is not mentioned in anywhere of any part of the modem which you're using, you just take a photo of that modem, ask ChatGPT what type of modem it is. It will completely give you whether it is Wi-Fi 6 or Wi-Fi 5 or what kind of it is, a latest modem or a very old modem. Okay. So this is a simple solution for our home where we are using only 200 Mbps or 500 Mbps per day. But for the bigger level place like data center, because in a second you are going to upload and download so much of data, at least 10 Gbps, that is 10 GB per second data network speed is required. It's a very 1 Gbps is there, 10 Gbps is there, 100 Gbps is also there. That is the max I have seen, 100 Gbps network speed. So BSNL, our Airtel, Sifi, here who else? Tata, everybody gives 100 Gbps also to data centers. So for that, the cabling will be very huge. So you know, right, the power cable has a different type of cable. Data cable is a fiber optic cable. Okay, so through fiber optic, only data can be pushed, power cannot be pushed. So power cable is a coaxial cable, I guess. So fiber optic cable or Cat6 cable is used for the data transfer. So that's the two types of cables that we have for the data transfers. So that will be huge cable will be connected, and through which through the modem switch, and then it hits the firewall. Then within that rack you will have a code switch. Through that the network data will be split to the storage devices, servers, databases, and everything. So that is a basic concept of network. Okay, I'm not going to the network layer. You have 7 types of network layer: public, private, etc., etc. I'm not going to that. This is a basic concept of network. Okay, that is how the networks are being split. Without the network power, we cannot make the server to access, server or storage to work, right? So the typical data center layout will be the top panel will be always a cable management, that is a network cable management. The power comes in separately to another place where in the rack you will have amps. Okay, through that, like a switchboard, you will have amps in it. From that amps, the power supply comes in. But for all the server storage and all the devices, the network comes in only through the top panel. So 50U rack or 48U rack, the top panel, 1-inch panel will be the network cable management patch. So through this, you will have 48 ports, 24 ports through which each device will be connected through the network, through the Cat6 or through the fiber optic cable. Why we use fiber optic cable is to have good speed. Okay, the Cat6, I think all the residential things are used only through the Cat6. Cat6, you could have seen a gray color tube cable, and inside that you will have multiple cables. Okay, if you would have seen some internet broadband cable, you will have a gray colored table, thickened cable. Inside that you will have small cables, and so that's a Cat6 cable. We used to see Ethernet cable, and that is sufficient for residential purpose. But for the high transfers of data, you need a fiber optic cable. That will be a very thin cable only, but it's very, very effective in transferring the speed of the data. Okay. And regular power cable is different. You know how that comes. The coaxial cable comes in a different way. So the top panel will be always for the networks port to be connected, and then comes to the switches. Okay. Then you have the firewall appliances. Firewall appliances in the sense, if in case you want the traffic to be filtered, you want the traffic to be checked and then go to the server. So in that case, the company will have firewall to it. And after the firewall, the data flows through the application server, through which it flows through the database server, and then it goes to the storage. Okay, if storage is there, if in case they have a backup storage on the same rack, it writes both parallelly on the primary storage and the backup storage, so that if in case primary storage is full or it is not reachable, then it writes on the backup storage also. At the bottom, you will have a separate space for having UPS, the PDUs or UPS. PDU is a power distribution unit, where I said like you will have this kind of plug points, right? That is called PDU, power distribution unit. And then you will have UPS for that rack. If in case even the power cut has happened, for that rack to work automatically, it will have some backup storage of power, that is UPS. So it's a simple solution which in the earlier days you had a desktop. For a desktop, you will have a UPS. Even power goes off through the UPS, your desktop will be working for 30 minutes or 1 hour. It is the same concept. Okay, so this is how the data center also looks. Any questions? Else I'll be keep talking. No questions?
Ma'am, as you said,
Yeah.
hello. Ma'am, you
Yes.
said fiber optical cables are used for data transfer.
Fiber optical cables are used for, sorry?
For data transfer, no, ma'am? For highest speed of data transfer.
Two things, CAT cable, that is Ethernet cable. If you go to your broadband, you can see only the CAT cable. So which to the max carries 200 Gbps or 500 Gbps GB per second. Okay, but to send a heavy data, it has to be fiber optic cable. A thin cable will be there. Okay, too
Yes, ma'am.
expensive. It's a thin cable. And then if in case you have to send 10 Gbps, 100 Gbps, then you have to use fiber optic cable. This Cat6 cable, it will handle only 200 Mbps, 500 Mbps, or sometimes 1 Gbps, but not more than that. But whereas the fiber optical cable can handle 5 Gbps, 10 Gbps, 100 Gbps data to it. That's the reason for having the Cat6 cable and the fiber optic cable.
Okay. But my question is, this fiber optic cable is being used for speakers also, ma'am. In my house, there is a small home theater like thing. Though they said to use fiber optical cable for better sound delivery and data transfer. And then I thought data transfer is only for like internet thing, but sound transfer also uses optical cable, which is a glass like thin thing, the small wire.
Be a Bluetooth speaker.
No, ma'am. It's a it is a home theater, ma'am.
Home theater.
With
See,
amplifier, some standard
for the
lens.
Bluetooth devices, right, where it works only through the Wi-Fi or a Bluetooth, they prefer for a fiber optic cable. Cat6 is you have to connect. Even fiber optic has to be connected, but it pushes data fast. It carries the data fast compared to the Cat6 cable, Ethernet cable. That could be the reason, but Maybe your this home theater device is having a high, maybe it is carrying a high speed of data. I mean, I'm not sure about that configuration of that device. Okay, if that configuration is like, if that device can handle a 1 Gbps data or 10 Gbps data, the resolution of the music is high, it's a 8D sound. Now it's all 3D, 4D, 5D is over, right? 8D, 10D has come,
Yes, ma'am.
even in the
Dolby
sound.
Atmos.
Yeah,
Yeah.
Dolby Atmos. So for those, I think fiber optic they may use because it pushes the data fast.
Yes, ma'am. So
Yeah.
So we use for sound protection also. So is there any new technology or new
But for the sound protection,
thing?
I should say it is for the data push.
Yeah,
To
ma'am, that is what
capture
I'm saying.
through Wi-Fi. Generally for Wi-Fi, I'm not sure for wired why they use it. Maybe nowadays the devices that comes in is a very high-end devices. Okay, that could be the reason they are using a fiber optic cable. Generally, Cat6 is enough, but see, earlier we had a simple camera, right? Where the resolution was only 600 into 800 something dimension was.
Yes.
Now it is not like that. It's earlier it was HD. Now it is asking 2K or 4K. You would have seen, right? More than HD, now the
Yes, ma'am.
resolution will come for 2K, 4K and all. So which means you need more data to be pushed in order to give the proper resolution, else the resolution will be broken. So maybe because of the advanced devices and the advanced thing, you need more data push to be very rapid. For that purpose, the fiber optic cable could have been used. That's my understanding.
Yes, ma'am. Is there any powerful cables other than optical
No.
fiber optics?
Apart from fiber optic, I have not seen any other powerful cable.
Okay.
For decades, for ages, they are using only two type of cable for the data push, that is Cat6 Ethernet cable and fiber optical cable. We don't have any other cables. Maybe the cable density is lessened now. It is very tiny thing, the fiber optical cable. But the fiber optical and a Cat6 cable is the two cables that carries data. Rest all we have for the carrying the power. To my knowledge,
Ma'am, is it possible wireless?
wireless is, in order to make your modem to work as a wireless, you have to connect the modem to some data cable, right? From switch to modem.
Yeah, ma'am. I'm talking about the data transfer now. You said data transfer is faster in optical cable, no? For this, in this speed, like 1000 GB per second, 500 GB per second, is it possible in wireless?
Of course, it is possible. It depends on the Wi-Fi modem what you have. If your Wi-Fi modem is connected to a 10 Gbps cable, fiber optic cable, then wireless will work fine. You will have 10 Gbps Wi-Fi. See, Wi-Fi is one of the method of transfer, right? The data can be transferred to Bluetooth, through Wi-Fi, through the cable, connected cable and all. But if you are making through Wi-Fi, you need to have a proper modem with antenna. So they will ask you to shake the antenna and see through which the data is coming in. So then, if that modem is connected to a proper fiber optic cable, you will get that speed. If that modem is not connected with the proper fiber optic cable, then you will not get that speed. If your modem is connected with a Cat6 cable, you cannot get a 1 Gbps data.
Yes, ma'am.
So Wi-Fi. Yeah. So these are basic things. If we try to understand from our home how this network works, and if in case you can just turn back your laptop and see how much kilowatt it is, how much it will support your mobile devices, then what you have to do is, if in case you can take a bulb also, 0 watts bulb or some 10 watts bulb and all, right? So 10 watts, then you have to put 10 watts into 24 hours, then into 31 days. That will be your EB if that light is turned on 24/7. Similarly, for you, if in case you're planning for any solar panel or anything, what you have to do is you have to go and check the entire devices, the electronic devices used at your home. You have to see how many watts it is. Okay. So then you take that watts, put it into 24 hours per day usage, into 31 is the per month usage. And then if in case this device works 24/7, this is the electric bill I will get, EB bill I will get.
Yeah.
So that's how we calculate for data centers. So whatever the server, the network switch rack, the storage unit, whatever we are going to mount, we first try to get the how many kilowatt it is supporting. And because in data center it is going to be 24/7, we will not shut down at all, right? So at least at house we use it based on the usage, like fans, ACs and all. But in data center it is going to be 24/7 powered until and unless physically we power off the devices, it will be running. So that's how we calculate power consumption and we pay to the data centers. Okay. So 15 rupees, 16 rupees is what the maximum. Currently, they are trending like 15 rupees, 80 paisa is what controllers was charging for us. So based on that, we just pay them. Similar to your house, how somebody comes and take the units consumption, even they will have a separate meter for the each rack, and they see how much consumption has happened, and into 15 rupees flat they give and they ask us to pay. So there is no slab, like here you have slabs, right? On 0 to 100 is free. In Tamil Nadu, it is free. I don't know about other states. If the consumption is less than 100, you don't have to pay. If it is 100 to 200, the slab is 2 rupees or something. If it is 200 to 400, again, there is a different slab, something like that. So, but in other states, I never heard about the free electronic, but your slab rate itself is very less, is what I heard in Karnataka and Andhra. So that's the basic thing. So if we understand our home, the gadgets, the devices, the assets that's used in our home, then it is easy to connect with the data center. It's all tiny here, it's all massive there. That's the only difference we will have. Okay, so as I said, the top panel will be always for the cable management. So from there only network cable will be connected to all the server, database, switches, everything. Then you will have a core switch. Then you will have firewall if there is a need. And then you will have application server and then database server, storage. Storage, you will have primary and secondary if there is a need be. And in the bottom, you will have PDUs, that is power distribution unit, and the UPS. So that's how a proper a rack in the data center will look like. Then the core infrastructure component, you will have WAN, wide area network, through which the internet connectivity comes in. You have router, the wide area network, and the internet connectivity. Then for firewall, you will have security, traffic inspection, segmentation. So if idThirdeye URL is https://idThirdeye.com, HTTPS says it is a secured one. So there is a default, only secured APIs call should be received. We don't want any untrusted API calls, is what is called HTTP and HTTPS. So then there will be a filter applied in the cloud that we don't want unsecured API calling to this browser. So for that, what we do is in the physical layer, we install a firewall. So where we have the software for security purpose, traffic inspection, and we do a segmentation also at the console level. And from there firewall, it comes into the internal network switch. So why we have a switch after the firewall is, once that API comes in through the firewall, once it is filtered, then you will have a internet and intranet. Only above the firewall, everything is intranet. It can come from a local area network, or it can come from a wide area network. The API can come from a LAN or a WAN or through internet. But once it hits the firewall, everything is considered like through the switch only it comes. It will be considered as an internal API, and then it hits the application server after the authentication and other purpose. It's application server. If application authentication also goes well, then it hits the database server in order to check the KYC of the customer. And if that also passed through, whatever a transaction happens or anything happens in the database, it will get recorded in the rows and columns, and that gets stored in the storage. If there is an external storage added, it moved to the external storage. And for that external storage, if there is a backup is also given, then it moves on to the backup device. So most of the organization tries to do the data backup on everyday night, EOD. They used to say end of the day. So end of the day, automatically from primary storage to secondary storage, the replication will happen. Replication is just they're trying to mirror whatever data is there in this primary storage. They will try to write it in secondary storage. If the replication is not happening, okay, then the monitoring team will say there is a latency. So backup is mainly for the disaster recovery. They will just take the backup, move it to a different location, to a different geography, so that if any issues happens, they will try to bring that data, put it back to the production and make the production work. Most of the time we will try to, if the backup has to go every day, it doesn't mean that we will schedule to move offsite every day. We will try to put it in a vault. The vault is like you would have seen in some movies. They used to show the bank, the bureau kind of thing. You open a vault, a big iron vault, and inside that we try to keep the media secure. All the medias will be encrypted. So only by scanning the barcode, we can decrypt and copy the data through the data restoration server, and then we can give that data for the future use. So 15-year back data, 20-year back data, everything will be encrypted and put it in the media tapes. And then we have to take that, scan the barcode, decrypt it, and take the data. So mostly we will do the restoration if there is a police case or complaint or fraudulent issues. So for that purpose only, it will be mostly used. Security zone, as I said, like there is an external zone, that is the internet. There is a DMZ zone. So any military stuff, right? It doesn't come through external, internet or anything else. So they have their own satellites, all the connections on all through the traffic data, all through the satellites, and it hits the demilitarized zone. You will not have any idea where it is posted, how it is hosted, how it is working and all. It is completely taken out of the sites of public or private. So you have public, private, and DMZ. So public is something like HTTP, private is HTTPS, and there is another thing called DMZ, demilitarized zone. Okay, so same thing. It's the web API, public services are there, but we will not be able to see how does that work. So, so what happens is if the API comes in from the internet and then it hits the firewall switches, before it hits the application, there will be a DMZ that through that DMZ, multiple authentication will happen, and then it hits the secured application. Then it, of course, goes to the database and storage. So that's the workflow. So then we have management zone. In management zone, we will just try to do a monitoring. We will say if API traffics are coming in on time, and then whether it is like all the APIs are getting responded, whether the request time versus the response time are proper or not, whether the backup is taken in the daily basis. So everything, the admin access, everything has been checked in the management zone. And we have firewall enforces traffic rules between the zones. That's too core. I don't want to take that. It will be too heavy. I'm just skipping it. Okay. And then high availability, as I said, most of the banking and payments domain will have primary, and they will try to mirror in the secondary. And one more backup is DR. So that if primary site, if Mumbai is not working, immediately they will fall back to secondaries in Bangalore, they will then fall back to Bangalore. If Bangalore, Mumbai, both are having some natural problem and couldn't work, then they will fall back to Hyderabad. Hyderabad will be a DR, something like that. Okay. So it's based on where they are positioning the DC, DR, and a backup. Primary, secondary, and a backup. So firewall in high availability cluster, yes, when you have 3-node cluster, the primary is called one node, the secondary is called one node, and the DR is called another node. We used to say it's a 3-node cluster. So firewall will be working in all the 3 nodes. Okay. And this all too heavy redundant codes because I have to go in depth for that. Like there is no need for that. So server clustering, load balancing. Load balancing, we have two types of Nginx. I spoke about Nginx earlier. So that's a load balancing server. Through Nginx only, any API can pass through, and then after it hits Nginx, it hits the firewall, and then it hits the application server, something like that, and then the storage. So by having this HA, high availability nodes, then you will have no single point of failure. So that if primary goes off, secondary goes off, no problem, still you can work from DR. So that the technical terminology is called SPOF, that is like no single point failure. Backup and disaster. Backup is taken every day at the end of the day. Okay, there is called as an incremental backup, decremental backup, but that is too technical. If in case you are going to work for the backup, then you can know about what is incremental, what is decremental, and weekly backup and all. But as of now, you just know the terminology incremental backup. So every day, if in case end of the day from a bank or from any a company, for example, 1 GB of data, the complete day's history is there. They try to copy it to one server, backup server, and then again they try to copy it in one media. So 2 backup or 3 backups will be there. So they used to take it in a daily basis. They used to take it in a weekly basis. They used to take it in a monthly basis. Also, they used to take it in a quarterly basis. So that is a segmentation of backups that they can take. So on-site backup storage is, as I said, there will be a vault. They take a backup, keep it inside the vault. Even the entire data center has some problem. The vault will not, even the high fire penetration will not happen. So that is how the vault will be designed. Offsite is taking the tape and moving to a different location, 300, 400 kilometers away from that location, and positioning that so that if this entire state is not operational, this backup will be kept, the offsite backup will be kept in a different state so that from that state it can make it operational. So that is the main reason for that. So of course, offsite DR site replication, then RPO, RTO planning, periodic DR testing and all, BCP and all is too heavy. That's okay. Now you don't need that. Monitoring, NOC is network operating center architecture. Server monitoring, so that is you have applications, you have application server, database server, you have storage, everything will be monitored. The 3 important components to be monitored in all 3 is CPU, memory, and disk. It's similar to your laptop. How does it work? If in case you try to open multiple applications, your CPU processing will go high, then you will have to kill some applications. So it's the same way here also. The network monitoring is you have to see whether, as I said, like you do an internet speed test, right? So here you will see if application goes down, is it because of infrastructure that is like CPU, memory, disk issue, or it is because of network, you're not getting a proper network speed where it is not pushing the data. It could be only 2 vital reasons. Either network will be slow or your CPU processing will be very high. So if network comes in with a proper flow, then you will get the inflow of APIs. Or if your CPU, memory, disk is performing well, you will get a proper traffic. So server and network has to be always monitored so that the application performance will be good. Even after, if there is no server issues, network issues, but still the application is not working problem, then it could be a problem between the application and database. The connectivity between the application and database might not be good. Okay, I'm just telling in a one-liner. The reason is only if you get into work in that, you will understand more about it. Okay, then we will see the log management, how there is an audit logs. Once the API hits the Nginx, from there, what kind of API callings had happened, whether the database responded properly, whether the storage happened properly. Everything comes in the audit log or SIEM log. That's a security something, even management log is what we used to say. So they check that. Alerting an incident. So if in case there is no API hit is happening for more than 30 minutes or more than 1 hour, immediately alert has to, even management has to give an alert that there is no hit happening. Check whether it is not network problem or server problem or application database problem. So NOC operations, that is network operations center, also works 24/7. Infrastructure monitoring also happens 24/7, and application monitoring also happens. Sometimes for banking, IMPS and all 24/7. For RTGS services and all, I think they stop for EOD purpose 2 hours, 3 hours and all. Few other companies, like, they work only 9 to 6, and nighttime they don't want their application to run. So for that, nighttime application monitoring will not be there. But however, server monitoring and network monitoring will be always 24/7. So that's on the monitoring side.
Yes.
So it's a data center best practices. I think this is the last slide we have. So network segmentation has to be proper. Then and zero trust. Zero trust is on network segmentation. It has to be uh, it has to be properly done, because see, there is called as MUX. How do I explain? I don't know whether it will be helpful for you or not. Through MUX, we get the internet connection through the switches, and like, and then it gets connected to the separate racks. Through that only it is happening. From MUX itself, if there is no speed of the internet is compromised, and it is not giving the proper push, then the entire rack doesn't get the enough network, and it doesn't work properly. So that's the reason they will say, like, it has to be checked properly. Okay, and redundancy for critical components. Always, if there is something redundancy in sense, if you have something critical, you need to have a backup for that. If you are having something critical and only one thing is working, if that goes down, you do not have a backup, then you will afford to have a lot of failures. So your application will not be available for so many time. Because of that, you will have trust issues, you will have financial problems. So because of that, they used to say any critical component should have a backup, else it will become redundant. Regular patch and vulnerability management. Of course, like your laptop, your server should also be getting a regular patch updates. If regular patch, like your mobile, your laptop, it has to get a regular patch updates, else the latest stuffs will not work. And the vulnerability management has to be there. The power and cooling optimization has to be done. If for an entire rack, if they give some 12 kilowatt, where you have only one server mounted in that rack, which is taking only 1 kilowatt, then you do not need to have 12 kilowatt given to that. So you can optimize, you can ask only for 3 kilowatt. So that's an optimization. So based on the usage, you have to pay. So that's what is called optimization. So physical and cyber security, documentation, and change management. So change management, this and all comes in on the ITIL framework, which I taught you. So first you will have event management, then incident management, problem management, then change management. That is the life cycle of an ITIL. This is also similar based on the ITIL framework only. They will build everything, let it be data center or application, whatever it is. So that is what they say. Documentation is core. Anything, any small changes you do or any problem has happened, you need to put it in the KEDB, that is known error database, and it has to be updated in the change management, so that they can go back and refer to what all the latest issue has happened, and they try to remediate it. So that's was little thing pending on the data center part, so I thought I'll cover that. Okay, any questions?
Yes, ma'am.
Any
No,
questions?
clear now. Everything's clear.
If in case you get an opportunity to work on the data center side, if you want more information or training about how does it work, that I can help you. Now, if I tell you, right, even more things I tell you, because of you don't have visualization of how data center works, how the switches, racks are connected well with each other. Even though I'm going to tell you, you will not be able to visually connect with it. So that's the reason I'm just giving a very high level information. Once you get an opportunity to work with that, I can probably explain you much more. Okay. Okay. Any questions?
No, ma'am. All clear, ma'am. Everything's good.
Vignesh?
No, ma'am.
All right. Anything that you wanted to know? from the corporate side. People are a little busy with the year-end activities and other stuff, so that's why I couldn't call you for your second Excel. That Excel stuff is pending. Excel training is still pending. I know that. I'll try to get the person. Apart from that, from the corporate level, or you looking for any other thing that you wanted to know?
Nothing much, ma'am. Already told some.
Okay. So, Gagan, what we have done is this is the 46th session. Okay, we'll be having another 4 more session.
Yes.
What I